What if I told you that the smartest AI systems on the planet, the ones beating humans at chess, writing code, and diagnosing cancer, are all powered by one deceptively simple idea? It's called a neural network. And in the next 4 minutes, you're going to understand exactly how it works. Welcome to Neural Networks, a visual deep dive. We'll explore what neural networks are, how they're structured, how data flows through them, and we'll even build one from scratch in PyTorch. Let's go. A neural network is a system inspired by the human brain. Just like your brain has billions of neurons connected by synapses, an artificial neural network has nodes connected by weights. Each node takes in numbers, does a small calculation, and passes a result forward. Here's the magic. A single neuron multiplies each of its inputs by a weight. Think of weights as importance scores. Adds them all up, adds a bias, and then squashes the result through an activation function. That activation function is what makes neural networks nonlinear, meaning they can learn incredibly complex patterns. Every neural network has 3 types of layers. First, the input layer. This is where your raw data enters. Could be pixel values, temperature readings, or word embeddings. Next, hidden layers. This is where the real learning happens. Each layer transforms the data, extracting higher and higher level features. Finally, the output layer. This produces the final answer, a classification, a number, or a probability distribution. During training, the network makes a prediction. We measure how wrong it is using a loss function, and then backpropagation sends the error signal backwards through every layer, nudging each weight slightly in the right direction. Do this millions of times and the network learns. Let's build one in PyTorch. We define a class that inherits from nn.module. In the constructor, we stack 3 linear layers with ReLU activations between them. The forward method defines how data flows through. Input goes through layer 1, gets activated, through layer 2, gets activated, then through the final output layer. To train it, we pick a loss function like cross entropy and an optimizer like atom. Then in a training loop, zero the gradients, run a forward pass, compute the loss, call loss.backward to propagate gradients, and step the optimizer. That's a complete neural network in under 20 lines of Python. Neural networks are universal function approximators. Given enough data and the right architecture, they can learn to approximate virtually any function. From image recognition to natural language processing, from protein folding to generative art, it all comes back to these simple mathematical operations stacked in layers. Now you know how it works. The question is, what will you build with it?